The question of whether the universe is infinite, whether it has boundaries, and what one might see upon reaching those hypothetical limits has long captivated human imagination. Modern science tells us the universe began roughly 14 billion years ago and has been expanding ever since. Intuitively, it might seem that an expanding space must have some kind of edge, right? In a certain sense, that's actually true. Our fundamental limitation in perceiving the universe lies in the speed of light. Nothing can travel faster. This means we can only observe those regions of space whose light has had time to reach us over the past 14 billion years. From our perspective, we see a sphere centered on ourselves. This is what we call the observable universe. However, the picture becomes more complex due to the universe's ongoing expansion. The most distant objects whose light we receive today are actually about 45 billion light-years away. Thus, the observable universe is a sphere with a radius of 45 billion light-years, containing roughly 200 billion galaxies, each made up of hundreds of billions of stars. So, for us, there is indeed a kind of boundary. We look back in time until that past runs out. This edge is essentially a temporal horizon, and in a physical sense, lacks tangible meaning. The real universe is undoubtedly far larger than what we can see. But just how much larger? There are two main hypotheses. Either the universe is extremely vast but finite, or it is truly boundless. A finite universe implies that, in principle, you could fill it with something, say, ice cream. You'd need an immense amount, but it would still be a finite quantity. However, this raises a curious problem. Such a universe would have to possess an edge, a cosmic wall where space ends. And if there's an edge, yet by definition, the universe encompasses all that exists. So how could there be anything outside of everything? Does the very idea of something existing beyond all existence even make sense? There is, however, one intriguing physical trick. A universe that has no boundary, yet can still be filled with a finite amount of ice cream. What if the universe is finite, but has no edge? Imagine an orange and a tiny ant crawling along its peel. The ant can see only a small patch of the surface, just as humans can perceive only a tiny fraction of the universe. But if the ant keeps moving, it will eventually circle the entire orange and return to its starting point. The peel is finite, but it has no edge. The universe isn't literally an orange peel, but it could be very similar. Instead of a sphere, it might be a hypersphere, where three-dimensional space curves back on itself. Unfortunately, the human brain cannot visualize such a shape. But the key idea is this: there are no boundaries, no outside to the hypersphere. From our limited, ant-like perspective, our entire three-dimensional space is analogous to the orange surface. If you flew a spaceship in a straight line, you'd eventually return to Earth. How can we make sense of this? Modern physics is highly complex, so we often simplify and slightly distort these concepts. In essence, it all comes down to gravity. Mass generates gravity, which curves spacetime. This curvature is strongest near mass, but extends outward like a faint tension woven into the fabric of spacetime itself. This could, in principle, curve the entire universe back on itself, forming a hypersphere. If this seems confusing, rest assured, you're not alone. If the universe is indeed a hypersphere, how could we determine its true size? On Earth, we observe ships disappearing over the horizon. Scientists have searched for a similar cosmic horizon that would reveal the scale of a spherical universe, but found no such evidence. This suggests that if the universe is a hypersphere, it must be so enormous that from our vantage point, it appears perfectly flat. To make this consistent with observations, a hyperspherical universe would need to be at least 1,000 times larger than the observable part, and possibly even 1 trillion times larger, but certainly no smaller. Some scientists have found this model too simplistic and proposed a bolder alternative. Perhaps the universe resembles the glaze on a donut. A hyperdonut is another concept the human mind cannot truly visualize. In such a universe, traveling in a straight line would also bring you back to your starting point, but with some curious complications. In a hyperdonut-shaped universe, the distribution of matter wouldn't be uniform in all directions. If two spaceships set off in different directions, one might return to its origin much sooner than the other. Light from distant galaxies would behave in strange, distorted ways, creating a kind of cosmic funhouse mirror effect. We might see the same distant object in two different places in the sky, and not only that, we'd see it at two different moments in time. Because light would take vastly different amounts of time to travel along different paths, you could witness a star being born right in front of you, while simultaneously seeing that same star die on the opposite side of the sky. Imagine how compact such a hyperdonut universe could be. Due to its unusual geometry, it might be the smallest possible universe, potentially only a few times larger than the observable portion. Or it could still be vastly, unimaginably bigger. At present, we simply don't have enough data to say. So far, but what if the universe is truly infinite, stretching endlessly through space? What would that actually be like? In fact, the cosmological model most scientists use describes the universe as infinite. We primarily apply it to calculate phenomena within our observable patch. But if taken literally, this model predicts an infinite universe. An infinite universe extends, well, forever, with no boundaries whatsoever. This is another concept our brains struggle to grasp. No matter where you look, you'd find more and more of everything, stretching endlessly in every possible direction. This is deeply disorienting for several reasons. First, if the universe is infinite, does that mean it's also eternal? Has it always existed? Was there ever a time when nothing existed anywhere, and then everything suddenly appeared everywhere? We don't know for sure, but we have overwhelming evidence for the Big Bang, indicating the universe did have a beginning at a specific point in the past. But wait, if the universe has been expanding since the Big Bang, how can something already infinite get bigger? Cosmic expansion doesn't mean the universe is growing into pre-existing space. It means the distances between galaxies are increasing over time. Even infinite space can expand. Welcome to the paradoxes of infinity. Yet the implications of infinity grow even stranger. If you traveled in a straight line through an infinite universe, you'd keep encountering new galaxies, stars, planets, wonders, bizarre phenomena, alien life forms more exotic than you can imagine. But after an inconceivably long journey, you might stumble upon the most unique thing in existence, yourself. An exact copy of you, watching this very video right now. How is that possible? Because everything is made of a finite number of particle types, and those particles can be... That number may be so astronomically large it feels infinite, but it isn't. If you have a finite number of possible arrangements, but an infinite space filled with matter in all directions forever, then, by pure chance, repetitions become inevitable. Of course, possibility doesn't guarantee reality. Maybe the universe extends forever, but only mundane configurations repeat endlessly. Maybe there's only one, you. But if the laws of physics are the same everywhere, then, far, far away, gas could have formed stars and planets where simple genetic information emerged from chemistry. That could lead to cells, animals, and evolutionary paths as improbable as our own, eventually producing primates who make online videos. It happened at least once, so the probability isn't zero. Even if the chance of an exact copy of you watching this video is nearly zero, that, almost zero, is still an enormous number in an infinite universe. Unfortunately, you never meet your twin, because almost zero still means the odds are vanishingly small. A planet identical to Earth today is so improbable that you need to travel about 29 times the radius of the observable universe, one followed by 100 octillion zeros, to find another one. That's not just far, it's forever far. Still, in a truly infinite universe, every possible arrangement of particles could exist, not just once, but infinitely many times. But perhaps it's time to pause. While these scenarios are mathematically plausible, we've now ventured deep into scientific philosophy. None of these ideas can currently be tested or proven. If the universe is infinite, we'll never know. The reality is this: for us, the universe is finite and has an edge, and we can see it. It's an edge in time. Everything we can ever interact with lies within the observable universe. Even if this finite universe seems small to you, it's more than vast enough to fulfill every dream we and our descendants could ever imagine. It's infinite enough for all of us.